folks. Well, here she be, the critter. This, I guess, little piece of test equipment, I suppose you could call it, for testing different aspects of a radio, I guess you could call it. Basically, what this project is. I guess it has 3 circuits built into it. One is a audio tone generator, and then we have a RF noise generator, and then we have what they call a harmonic comm generator, also built into this thing. It's built around a crystal oscillator. Not good, not bad at all. And, let's have a wee peek, shall we, at what you look like on the inside. Spent a few nights building this thing. Started last weekend. Right now it's Friday evening. And this is the 3 circuits built. Right now, like I say, I have a 50 megahertz crystal oscillator here. We'll be looking for a different one. If I get this a 10 megahertz crystal oscillator, that'd be great. Even a 5 megahertz would be better again. So if anybody out there has one of these, has a lower frequency, 50 megahertz, let me know. 50 megahertz is a bit too coarse for what I want to do, but it does work. So basically, right here is the audio tone generator. The interesting circuit, to say the least. It runs off a speaker. A relay for switching the power on or off. It's also controlled by the front, I guess, circuit selector here. The relay itself cuts these circuits in or out, so there's no interaction between circuits, basically. That's the way I want it to be done. So this is the audio tone generator. It's a fairly simple circuit for the most part. I had to use a 1.2 or 1.3K resistor on the emitter of a 3904, because this one would get mad hot, and I mean vicious hot, without this resistor in place. I also had to add a little variable resistor here to control, the coarseness, I suppose, or a fine tune of the tone for the speaker. So I had to add this fella in there as well. The next contraption I built here is the RF noise generator, or white noise generator, whatever you want to call it. This circuit would not work on 9 volt, so I had to bring in 13 volts from the main supply. From here, as you can tell, has 13 volts in, and it comes on to the relay, and the relay gets switched on or off by the main switch, and it comes back in on the orange wire to the circuit. So that's how that one is fed. And then we have, of course, the harmonic comm generator. The whole circuit basically is only 3 parts for the most part. You have the crystal oscillator, obviously, which is this part here. Then we have a 22 or 27 picofarad capacitor. Apparently this capacitor ain't that important as such for values. Apparently can go from like 20, I think it's 22 nanofarads up to 100 picofarad little work here. I have a 33 picofarad since it's close. I got the 27 picofarad, so I went with 33. And of course that goes off with the RG174 coax to the BNC connector, and you have the diode, which is a 1N4148 going off the ground. The other BNC connector with the yellow wire goes back to the white noise RF signal generator, or RF noise generator I should call it. Basically this circuit, if you're trying to repair a receiver, say a CB radio or something like that, and you want to check the receive to see if the receiver is actually doing anything, basically you can hook it up to the RF noise generator, and it sends a huge amount of, I guess, broadband frequency noise into the receiver. I'll show that what that actually does now in a few minutes. I'll also show you the tone generator now very shortly as well, and the harmonic comm generator. But right now, as I have it set, I have the audio tone generator is hooked up with the meter for fine tuning, because it's such a close, let's just say, in order to get the speakers out to start oscillating with this circuit, the control has to be in a pretty fine spot for the circuit to start functioning. And how it's set up is with the variable resistor here and this pot potentiometer at a certain position to make this needle on this meter go centered. When the needle is centered on the meter here, the speaker here will start oscillating the way it should be. If it's up too high or too low, the speaker won't oscillate. So there you go. That's the purpose of the meter. So let's power this beast up and show you how this thing looks on a scope. Again, the scope I got is 32 megahertz scope, so right off the bat it's not going to be high enough for this 50 megahertz crystal oscillator, but it'll show you something on the screen to let you know the circuit's actually functioning. But there we have it. Anyways, let's get the scope on the go and hook this thing up and see what it looks like on the monitor. Alright, so circuit is here. I got the main power switch. Turns on the whole contraption. Meter lights up, and then of course we got switches here. 3 LEDs in the front. We have red, yellow, green. Got a loose connection up here. Just got these wires kind of pushed in here, but get in there. There we go. So again, we have LEDs here. 1, 2, 3. They correspond to the LEDs here. 1, 2, 3. So you get green. It's this one. Gotta love the loose wire. Come on. Stay on there, you bugger. There we go. Yellow is this board, and then we've got red, which would be this board. So let's move over to the tone generator here. We'll get this one tuned up here, and we'll be right back. Okay, so what we'll do, we'll start with the tone generator right here, audio tone generator, and again, this is the tuning for that generator, and obviously it corresponds with the meter here. So I'll just show you on the meter as I'm turning the control here. And as you see, needle has to be centered. Right now it's centered, and it'll stay there all day. So basically, this being controlled by this control. this speaker. I know, isn't it? So we'll show you how I intend to use the speaker now shortly. So now let's get the noise generator going here, the RF noise generator, and show you on the scope what it looks like, as well as what it sounds like on the AR8600 or AR8600. So let's get this board powered up. Okay, so now I have the RF noise generator running here, and I have my probe for my scope put right on the yellow wire, ground, and this is what it looks like on a scope. So I'll just turn it off for a minute. Turn it on. So you can tell that the circuit is generating a noise for sure. Alright, so that's just speeding up the signal. Now we're going to pretty much lock onto the signal, and that is what it looks like on a scope. I know it don't look like much on a scope, but let's take this same signal, dump it into the AR8600, and see what it sounds like. Okay, so right now we have my AR8600 hooked up here. It's hooked up directly to the back of the unit here, and so now we're going to switch her over to yellow LED, which is the RF noise generator. Now, if y'all look back, remember this contraption here that I built way back when? Well, this circuit here is exactly the same circuit that I have built inside of this case, this cabinet. Same circuit, no different. RF noise generator. This is the exact same thing that's built here. So you've seen how this one worked. Well, let's turn the generator on and look at the noise, or the S meter on the 8600. Just put it off. Let's put it on. The noise generator works over a pretty broad spectrum of frequencies. Basically covers everything from long wave right up to 30 megahertz. So I can go 10 megahertz, 5 megs, 500 kilohertz, or 150 kilohertz. And turned off. And there we have it. So we know the noise generator is working. Now, let's hook up the 50 megahertz crystal oscillator that's built into this thing now, and you'll see how that works with the AR8600. Okay, so for this demonstration of the 50 megahertz crystal oscillator on the green LED, well, what we have here, we have a watt meter in line dumping into a 1 watt 50 ohm dummy load. So the signal is going to be just dumped into that, and that's it. Then we're going to receive it here on the AR8600. So as you can see right now, there's no signal on the screen. So what we're going to do, what I'm going to do rather, is I'm going to turn on the crystal oscillator, and you'll see a nice little signal on the screen. Ready? There we have it. and the circuit puts out, milliwatts, mere milliwatts, but just enough to move the needle. So that's mere milliwatts that 50 megahertz crystal oscillator puts out. So you could build, I suppose if you wanted to, you could build, or I suppose if I wanted to, I suppose I could build a 50 megahertz RF amplifier for that matter, and increase the signal. If I want to play around with RF circuits, I suppose I could play with little amps, I suppose, if I wanted to, but that's not what this is for at all. So again, if anybody has a 10 megahertz crystal oscillator module, such as what I'm using here right now, I got a 50 megahertz. If anybody got a 10 megahertz or a 5 megahertz crystal modulator or crystal oscillator module, I would love to get my hands on it. So put her in the green position. And there we have it. So I suppose technically, if I really wanted to, I could get in another relay and take the RF signal from the RF oscillator, put it into a 50 ohm dummy load, and then get a indicator on this S meter, I suppose, if I really wanted to. But here we have it. So let's just move the frequency up the band. You'll hear this every 50 megahertz. So right now, of course, the crystal is a 50 megahertz oscillator. So of course you get a signal at 50 megahertz. Then we go 100. You get a signal. 150. 200. 250. Of course, the higher in the band you go, it gets weaker and weaker. To a point, it just disappears. But there we have it. Now, let's put the audio tone generator to use and show you how I intend to use that circuit in repairs. Okay, folks, so you might know what I would use the tone generator for. You want to say hello to you, Tabby? You want to say hello to everybody on YouTube? Huh? You want to say hello to everybody on YouTube, Tabby? No? You're going to turn your back to them all, are you? Huh? Tabby? Say hi. Alright. Anyways, so you want to see how this thing works. Well, let's turn the light on here. Alright. So this is how I would use tone generator. Basically, we have our microphone. There's another thing I like about this microphone. With a normal PDT, you got to press it and on keys. It's like that, momentary switch. This thing has a toggle switch to turn it on or off. Good for tuning SSB radios for power. So basically, all you would do, put right on your favorite frequency, in my case 23, and we'll put the tone generator on the red LED, and then we'll watch the power meter up here. You will notice we are in upper sideband. So we're going to key the microphone, watch the power. We have no power unless I talk. As you can see, nothing there. So let's turn on the tone generator. And here you have it. So it modulates the transmitter. Solid. Generator off. PTT off. PTT on. No power. Generator. And there we have it. Now turn the mic off. Done. So that's the purpose of the tone generator. To inject a signal into my microphone so I can adjust the output circuits, the RF circuits of an SSB radio. There you have it. So I think overall, this project came in handy. Came out rather well, if I have to say so myself. But there we have it. Anyways, hope you enjoyed the video, folks. And what in the world am I going to build this weekend? I guess we'll soon find out. Until then, what'd you build out of your junk box today? I built that thing. That's awesome. Anyways, I'll chat later. Oh, what's more awesome than that is this microphone. This is deadly. I like this mic. This is a wicked mic, I got to say. Loved it. Anyways, enjoyed the video, folks, and we shall chat later. Reno 63. We're out of here. 7-3. But before I go, let's hear what the tone sounds like on upper sideband on 27255, channel 23. Keep the tone going. Have a listen. There we have it. I think it works. Marvelous.